So we'll continue our network theory which we were talking about. We will go with a very simple network. We were talking about this simple network. We told about the constraints which we can place on that which you can put on the network, and beside the constraints, we can also use. Just hold on for 1 minute. I'd like to have this recorded. I hope people will find this useful. So just 1 minute. Right. So we were going through the network. So we told that network can be on various levels. We told about the L1 to L5 schedules. So if you can keep drawing networks up to any level you want. One of the biggest advantages of this network is the network gives you an idea as to what activity is there and what activity will follow or what will be preceding a particular activity. And typically what happens is in the computer, the regime where we are using a computer a lot, we find that people start to use the computer too much. So they feel, okay, I can go to any level of detail. So they keep adding activities which may not even be relevant, which do not have any bearing on the project at all. And when you look at it from a very large picture, you are essentially getting a very distorted image. You feel that it's more complicated than what it actually is, and it doesn't really help the process. So we are now going to have a few definitions. Okay, we are going to now put values into a numerical way. So we spoke about the early start time, early finish, late start, late finish, etc. So you just go through these formulas which are put up. And do you have any do you have any doubts or any concerns as to why these formulas are coming in? So basically early start is nothing but the time, the time when the previous event gets over, only the earliest we can start, right? For instance, this lecture cannot start before 5 o'clock. Before 5 o'clock there is no chance that this can start because previous lecture was going on. So before, for instance, the excavation, there is no way that a foundation can start. Okay, so that is how we get this early start coming into picture. Then we have the other thing called early finish. So this early finish is nothing but the start of the activity plus the duration. So if suppose the duration of this lecture is 50 minutes and the start is 5 o'clock, what is the earliest we can finish? 5:50. Yes, you are right. Okay, so basically that's what we have, early start plus activity duration. So late finish, of course it goes with the late event of the following event. So how late you can have the how much you can delay the next event. So that essentially is the late finish. So also the late start, okay, late finish minus activity duration. So we come from the backward when you are doing the late. So then you have the total float. You have two definitions. You either can subtract the late finish with the early finish, or late start from the early start. Both of them will give you the total float. Okay, total float, or the time which you can you have as a free time. Okay, that is what will not affect the project. Okay, and what is the critical path? Critical path is the route which has zero float. Okay, critical path which has zero float. Now this is the problem which we are going to have. Remember, when we were making the activity diagram, we were making the precedence. Okay, so we have the precedence put in, then we have the description of the activity, and we follow it with the duration. Let me just get my pointer on. Okay, so we got the activity numbers. Okay, so this activity numbers we call it as an IJ format. Okay, IJ format means when you are going to draw the activity chart, you are going to have the start as the ith node and end as the jth node. So here you have I, j. So the activity number 1, 2 means it is between 1 and 2. That is, starts at 1 and ends at 2. And the description here is just for a borewell, okay, for a simple borewell. First you have to drill a well. You have to bring all the materials which are required for it. Then you do a little bit of excavation. You have to bring in the power line for the motor. Then if suppose you have to have a tank, a small tank near there, you can just put it into place, like maybe it's a prefabricated tank, you bring it and assemble it in place. Put the foundation, lay the foundation for it. Excavation is done, then only you can do the foundation. So on and so forth. Okay, so excavation is between 1 to 4. You can understand it here, it is 4 to 6. So after fourth activity is over, this foundation we will be putting in the diagram. That would be activity number 6. Okay, so in any case, have a look at this. First is you drill the well, then you go ahead for the pump house, you bring the power line, and the other side you do the excavation, and then you again, you know, like you install the pump only after you finish the excavation. This is a dummy activity which we have marked. So on, we have also the excavation of the foundation, then the installation of pipes, and everything is ending in number 7. Everything is ending in number 7. So you can probably just make a note of this sketch. Just go ahead and make a note of this. If you want, you can also take a screenshot of this. The idea is that you are following the diagram, okay, because otherwise it is not going to make sense. Okay, so please, I think I'll just give a little time for you to take down the diagram. So you will, what I expect is, I want you to just have this list when you study the relationship in the next slide. The next slide is the drawing, the diagram. If you are able to actually take a screenshot from that point, it's absolutely great, your cameras, okay. So now you have a look, please compare what you have there with this one. So if you see, you have 1 to 2 drill well, okay, 1 to 2 drill well, the duration is 4 units of time, okay, the duration is 4 units of time. It can be 4 hours, it can be 4 days, it can be 4 months or 4 years also, okay. So the duration of time is strictly based on the type of project which you are doing, okay. So what many times you will see is, on your software, like a scheduling software, the timeline can be given in quarters, that is every 3 months, or in half years, so on and so forth. You can divide the entire process. So also your L1 schedule, the L1 schedule can be even in years. For example, if the Hoover Dam was to be programmed, you will be putting it in the order of few years. Excavation, river training works, 2 years. Then excavation work, another 3 years. Then mass concreting, or like soil stabilization, another 1 year. So like this, the entire project would be in years. So total completion 10 years in your L1 schedule will be put in that scale. L2 schedule may be put in probably few months, in the order of a few months. So what I am going to do, I am going to do stabilization probably by compaction or grout. So whatever you want to do, you can put it in your L2. But when you come to L5, it may be even in the order of a few hours. Okay, so the this one curing has to start after so many hours. So this will be done by such and such person. You can drill down to such details also. So this unit of time is something which is a little variable. Now I will also encourage, I mean, like, I hope you have been able to go through this. Just go through the other points also. The construction of power line, this is the duration, and it goes from 1 to 5. So you see, power line duration is 1 to 5. So on and so forth, all the things are marked. Now we are coming to the little interesting part. Here we've got the durations, we've got the activity numbers, you've got the activity chart also. Ideally, this will be done on the blackboard and you will be following it. However, because of constraints of size of class, etc., I am not going to be able to do that. So here I've just worked this out in Excel. In fact, any of you can try to program most of this stuff in Excel. Once you are able to get this activity chart, relationship between activity understood by Excel, like probably instead of keeping both in the same column, I say 1 to 2 start and end, you can easily work out logics to make Excel do the calculation. Okay, now all these things which start from 1, now that is 2, 3, 4 and 5. Okay, 2, 3, 4 and 5, they all will have to start with the 0th interval in time. So that's why we got all of them in 0. Okay, so automatically early finish will be the early start time plus duration. So you just add 4, 2, 5 and 3. It's just 3 plus 0, 3, 4 and so on and so forth. Now you come to 2, this pump house. The preceding thing is activity number 2. Okay, when is activity number 2 getting over? It is getting over after 4 days. It's getting over after 4 days. So this can only start after the 4th day. This is what is being marked here. Okay, this is what is being marked here as the early start. Early start is 4. Now you have got the early start. You got a formula. What is the early finish? Early start plus duration. So it goes to 7. So again you come here. I'll just do this. We'll just go through this. Early finish of activity 3 is 2. Okay, so early start can only be 2. Duration 4. Hence 6. So are you able to work out? Are you able to understand this logic as to how this is going? Okay, so this is called as the forward pass. Once you do the forward pass, you are going to have a diagram which looks like this. So after 4 days, then here 4 plus 3 is 7. Okay, here this is coming at 5th day. So what happens essentially? So you can just see the slack which you can get when you come through various routes. So 5, again 5 plus 6, it is 11. But another route is there which is going to take 15 days. Okay, so this is essentially how we work it out. Okay, so because this is 15, because this item is 15, see I can only start after 9th day because 7th activity has to get over. And when is the 7th activity getting over? Earliest finish, it is 9. Okay, it is at activity number 9. So where is this? Where is 9? Sorry. Where is 6? 6 is here. Okay, 9 plus 6, we are getting it as 15. Okay, so this 9 is coming because of this route. 5 plus 4, 9. You got 2 routes, 2 and 4. It is nothing but 6. Another route is there, 5 and 4. Which is more critical, or when can the next activity start? Only after everything that flows into this node gets complete, we can go on to the next activity. Okay, do you have any doubt in this? May I suggest that all of you just try to do this forward pass by yourself. You now got you got that sketch. Okay, can you try to get this table by yourself? I'll do one thing, I'll just come around a little. If you have doubt, you can ask. Okay, it's very easy, just needs a little. Yeah, probably I want you to get this table. So I will keep the chart on the, I'll keep this chart. All of you got this sketch, right? Hey, come on, yes or no? Okay, right. So now I got a diagram for you. So you just try to work out the various parts on that chart, on that table. Yes.
So why are we not taking this? Why are we taking this from 1 to 4? It's 5. Then 4 to 6, it is what? 4. 4 plus 5, that is 9, right?
Which one? 4 plus?
1 to 4.
5. Okay.
That is 5. 4 to 6, if we are going, then 4. Then that 5 plus 4 is 9.
Yes.
Why are we taking that path? Why are we taking just 1 to 3?
See, 1, 2, 3 when I finish, first it takes 2 days, then it takes another 4 days, 6 days work is over. So to come to node number 6, doing all these activities, it took 6 days. But to come through the other route, it is taking 5 plus 4, 9 days. Next activity can start, whatever flows outside this node can start only after all the activities that come to this node are complete. Only if everything which comes into this node is complete, I can start the next one. So that is how the early start of the next activity gets determined. Okay. Usually dummy activities, when we are having more than one flowing into it, that time we will put it. So that table doesn't have anything to indicate it, that more than one thing is there. Yeah. Tell me.
After excavation is done, the pump should be installed. So there is a dummy between. There is no time gap, but only after
Between excavation.
This one 1 to 4 is excavation, sir. Only after excavation the fifth activity can start. So they just kept a dummy thing. There's
Yes.
nothing like time there's no activity between 4 and 5.
4 and 5.
But only after excavation the other thing can start.
You are right. Hey, look here.
But that should
But actually that will be normally put as a constraint. Okay.
It should be mentioned.
It should be put as a constraint which is not actually seen there in that activity chart. So that is why I want to go and look at it properly in leisure, because other concepts are clear. But I just want to see that clearly and then put it in, tell you. Yes. If it is, see, that is not mentioned, that constraint is not mentioned. So I don't want to open my mouth before I am confident. Okay. Maybe I missed some part of that question. So in that case, I'll have to put it in place. Usually whenever we are having that early, I mean like, not before some constraint we put, it will be easy to get it. Okay, any other, I mean like you guys have got any doubt? Hey, get it done. If you try to do this only, you will be able to work it out, okay? And those of you who have done OR, I'm sure you will not have to worry much on this. Okay, so this is the forward pass which we have, and one of your friends rightly pointed out, see, if there is a constraint between, I mean this installation of pump cannot start before excavation is complete. So for that we are giving this dummy, but that constraint we have not shown, okay. But I want to also just verify by myself before I come and tell you, okay. So we have finished the forward pass. Once you get the forward pass done, you get the early times, okay. Now we do the backward pass. That means we start from, we now know 15, okay. 15 is the time when we finish, and we keep finding out how late we can do the activity. So basically you will find that yeah. So if you are looking at our detail here, 15, and what is the duration which we have? 6. So 15 minus 9, 15 minus 6, you are going to get 9. Okay, so again same thing. Now you have a look here, we are going to go back on this loop, 7 to 5, this loop. Okay, so here if you have a look at this, your duration is 2, so 15 minus 13, 2. First what we did, we came from the front, we came down like this. Now we are doing a backward pass. The same thing as to what was done for the forward pass, we are now doing, but instead of adding the duration, we are subtracting the duration. I'll just like to remind you that these are the formulas which you are going to do. Okay, this is the formula which you are looking at. Okay, late start, late finish you find out first, and from late finish you keep working out the late start. First you find out the late finish, how late we can finish an activity, and then from that you go on to find the late start. Okay, that is by subtracting the duration. So you keep on when you keep on go like that, you come back to the start, and then you are getting the late start and late finish. Okay, so this is the way you get the late start and late finish. Just see, if suppose you are able to get these values. If you have any problem in getting these values, please ask. In the previous time, what we did, we kept finding the loop in which we are going to find, which is having the longest duration. So we see all the activities that lead to a particular node. We see, we ensure that we find out what is the longest time which it will be there for that to get complete, and that forms the early start for the next activity, so on and so forth. Here we are doing the reverse. Instead of looking at start times, we are looking at the finish times. How late we can have the time. So we cannot exceed 15 at any point. Then we keep subtracting the durations, and then we back work, and then we get this table. Okay, so please try to get this table in place. So you have your diagram, and then you have the activity numbers. Can I put the diagram on the screen? I think that will be better. So the result should be this one. Okay, I am putting the diagram now. So early start is marked on this diagram. Okay, see, this is another way of doing it.
Can I do it?
You can do it, I have no objection. See, I wanted to do this next, as the next step of this.
I will do my in examination point of view. Can I do
Exam point of view. Hey, look here. We are having some very particular rules like activity on node, activity on arrow, or stuff like that. Okay, this is a precedence diagram, basically. If a precedence diagram is asked, please do it. Okay, if you want to work out the solution, do it. But once you work out the solution, put it back according to what the question is. See, we are having, there is a chance that in the exam, I may not be the one who is evaluating. Okay. I'm sorry? Okay, it might so happen that I might not be the person who is evaluating, but I will be giving a key. And in that key, if suppose the diagram is not there, you may lose the mark. He is having a precedence diagram which is also correct, which is also the right way of solving. There is nothing that this is only the right thing or wrong thing. However, when a particular technique is asked, we are expected that the technique, understanding of the technique is understood. You do it in the last and rough, put it back in this. I am sure you can do that, right?
Yes.
So, precedence diagramming, you will have early start, early finish, everything put in place. The diagram will look a little different, that's all. So, basically, yes, I want you guys to go through this thing. Hey, you need you have to have that other chart. Okay, the first 1, 2, etc. was marked, right? But anyway, that is again put here. You can, yeah, you, in fact, even this time is put here, so you can easily work it out. Fine. We will just try to do 1 or 2 loops. Okay. So this 15 minus 2, anyway there also it's going to come 7, because there's no other way I can start it. Now when I have this as 7, look at the precedence for the others. 15 minus 6, it is going to be 9. So 7, this is 9, and other loop by which you can go, you can come by this one. So 15 minus 6, again this is 9. So you will be keeping on back working on each of these nodes. Okay. So once you do it, just see whether you are getting this result on the backward pass. Okay. So if you see 7, 4, 15, and then you have to go for 6, hence you get 9. Okay. Now you have 9 as the critical thing. So late finish 9, and then what is the duration 4? So basically it is very simple math only. Okay. So the solution is something that looks like this. So 15, here there's 15, 6, 9. 15 minus 6, again 9. So you got 3 loops. So when you come by this loop, this is the dummy activity, so 13, then you got 9, then you got 5. Okay, so that's why you got the 3 values in brackets. Most critical is this 5, so that's why this is appearing here. Okay, so 5 minus 5, again you will get 0. Then let us look here, 9, no other root is there, so okay, so that is why you don't have any brackets. 4, that is 9 minus 4, you get 5. Again you got 5 minus 2, the most critical value is 0. Okay, so you do have 3 on this root, but you got 0 on this root. Now you see, that means when you come by this root, you don't have any free time. There's no free time, there's no slack. So this automatically becomes the critical root. I can come like this, but I could have come also the other way around. But had I come by that root, I still get a slack of 3. Okay, so this is the way by which we see which will be the critical root. In fact, this formula is just, you can just subtract late start and early start, or late finish and so on, and early finish. Okay, so 10 minus 4, it is 6. So you keep doing this, you get a root where there is 0 float. So that means 1 to 4 has 0 float. Okay, then this root has 4 to 6 has 0 float, and then 6 to 7 has 0 float. When this is highlighted on the diagram, you will call that as the critical path. You call this as the critical path. We will just go through this one more time very quickly. First, you make the diagram based on the activity number which has been identified. You got the activity numbers. Once you get the activity numbers, put it in the diagram form. Once you put it in the diagram form, you will be putting the duration and the activity. In this case, the activity is put on the arrow. So this is called as an activity on arrow construction or formulation. Okay, so you can also put everything on the node. So if you put it, you can put late start, early start, and early finish, late start, early start, late start, then early finish, late finish, and also the duration with the activity description on this node. Okay, that's the precedence diagram also, which we can also put it as. So once we get that in place, you are going to have like you will get the same result, but it's a different formulation. Okay, that's just a different formulation. So once you get this in place, you go for the forward pass. You know the duration and you know the root. So keep finding out which the early finish which you can actually do for the activity. Early finish means all the activities have to get completed when you exit that node. So then you keep going for the late start. For getting the late start, you come from the back. How much you can put the activity beyond the start and still manage to get the work done. That's what you try to do. It's the reverse. So you see, for instance, in this loop, in the forward pass, you get 3 values. 4 plus 3, 7. There's one 3 or 5 with a dummy. Because dummy has 0 duration, you get 0 here. So it's just 5. So you see which is the most critical value, and then you keep proceeding on. In this case, you will find that 5 plus 4, 9, 9 plus 6, 15. So this is coming 15 because this gives the highest sum. Okay. So then you come the backward pass where you go from the finish. You keep back working the values from the finish and you get back to the start. The roots which have 0 float, okay, the roots which have 0 float constitute the critical path. Okay. So with this we will stop